you should be able to see my screen now, right?
Yes.
Is it too small?
It's a little small, but that's okay.
Let me just.
Yeah,
Uh,
that's a little better.
that's
Thanks.
talking me big on my end. So let's hope that. All right. So I hope folks can see the screen and can read the contents. So so this is a. Ooh, I'm seeing. Let me just pull up the chat as well. Uh, okay. Yeah, so also feel free to interrupt me if I'm ignoring your questions in the chat. That's always possible because it's kind of hard to focus on multiple things at the same time. So if I'm not answering your question,
I'll monitor the chat and let you know.
okay, thank you. All right, so the idea is that we want to provide users with really the like a flexible tool chain to use the Superfacility API. And so to this end, I think this is not limited to Julia. I just wanted to show the Julia. What is it? It's not really a client. The Julia interfaces as an example, but in general, we are experimenting with all sorts of languages at NERSC. And so keep in mind that this Julia interface, the Superfacility API, is a work in progress. And bug reports and like issues and pull requests are actually an excellent way to signal that you're interested in something, and that will help us move things along, and also help us prioritize where folks want us to focus our development efforts. So with that out of the way, let's take a look at the Superfacility API interfaces in Julia. Now, the package that's responsible for interfacing with the Superfacility API is called superfacility.jl. And in general, the way that folks manage Julia, the recommended way that folks manage Julia environments is using a environment file called project.toml. So if I were just to open it, you can see like this is one example of an environment, and the Superfacility API is in here. And so if you don't know what I'm talking about and you're a Julia user, I really recommend look at the PKG documentation. It will save you a lot of time and effort. So one example of how environments help us is they ensure that we have a consistent set of dependencies. So in Julia, what you would do is you would run this code here. This is just a macro for like the current working directory. So if I was to expand that, you can see this is where I'm on my laptop, and like beside the Superfacility JL demo completed notebook, you'll see the project.toml. By the way, if you don't, you'll have to pull you just have to do git pull. You might have an earlier version of the GitHub repo. Now, once you've activated your environment, so now you're kind of working inside the training environment here, you can use the instantiate command, and that will fetch all of your dependencies and all the dependencies thereof. So if I'm just gonna run this, it's gonna take a couple of seconds, and there you go. You can see like it's gone and grabbed all of these dependencies. And you'll see it will have made a manifest.toml. If you actually ever wanted to look at this, there you go. But really, this is not meant for humans to read. This is just a record of all the dependencies that are specific to your operating system and your Julia version. So that's also why I recommend you use instantiate rather than just copying a manifest.toml around. And if you're paranoid, you can take a look at your environment and you can see we've got all of these things now installed. All right, so I'm gonna just import a bunch of useful packages that we will use later. And to use the Superfacility API, you would use the SF API module in the Superfacility package. Let me just do that. And now we can start to actually do very similar stuff that Nick has shown. I want to also point out that the Julia, when you say something is Pythonic, I still don't know what it's what word you would use for Julia, right? Is it Julian? That sounds like I'm some sort of party member in ancient Rome. So the Julia way is often pretty low level. And the design of the Julia API, Superfacility API, kind of reflects that. So for example, we expose the query module, and then within the query module, you have get and post and so forth. And that really reflects what we can do, what you've seen Björn talk about. The idea is we have convenience functions layered on top of that, but you might, if you're using Julia, you'll probably be trying to do some low-level hacking. So we didn't want to obscure that. And so if you did use the low-level API, I'm just going to run this command now. You will get results that look a bit like this. That might look a little scary initially, but what it actually does is it is a result type, just like in Rust. And so this can be an error or it can be a result. And then it is the payload of the returned query. And so if you don't want to do low-level shenanigans, then, for example, you can pass the output of the low-level API to the status frontend, center status frontend. So if I just were to do that, you can see now it's cast the API output into sort of a very Julia-centric, it's a vector of status entry objects, and they all have different data. Now, you might find this is not very helpful, right? Like you might only care about Perlmutter. So what we can do is we can now take vectors like this, and we can filter them for certain criteria. So one thing you might want to do here is you can see that I'm not typing like Nick, by the way, because I don't trust myself to make typos. But we can take this list of center status objects, and then we can look at each one of them and check if the name is equal to Perlmutter, and we will take only that. And Julia has this way of making sure, like sanity checks, so making sure things crash where they're supposed to. So this only function says, I want exactly one element, otherwise I'm going to throw an error. So if I were to run this, you can see, okay, we only get the Perlmutter result back. See if I was to put something else here, we'll get an error, right? That we want exactly one element. Right, there's only one Perlmutter, so we should only get one status for that machine. Some people think a bit different. This is sort of function call notation. Some people like pipelines. And so we can do the same thing in pipelines, right? We can take the center status API output, we can pipe it into a filter object, and we can then pipe that into only, and that really does the same thing. It's really a question of taste. And I'm not going to judge anyone's taste here because, we all think differently. Now, you might also have already noticed that there is a Perlmutter status argument. So we can streamline things a little bit. Rather than passing everything and then filtering, we can ask the Superfacility API to filter for us. And for example, we can just run this, and that just works. And oh yeah, and one more thing. These Perlmutter status objects, they are classes. So I can go and use the question mark operator on the data type, and it will just tell you oops, sorry, already imported that. So it will tell you that these are the different vectors, so the different elements in the status structure. So name is one of them. Oops, sorry, and status is one of them. So if I can just reference them directly. All right, and finally, again, as this is a question of taste, you'll see stuff like this throughout this notebook, because this is sort of the way that I can keep things in my head. In Julia, we have this chain package, and that allows you to basically chain function calls. So the way this works is we start with this function call, and then we put we just send the output into this, and then we send the output into the underscore of the filter operator. We send it to only, and then, for example, we just take the status field. So you could do something like that, for example, and you achieve the same thing. So it's sort of like, does your brain work vertically or horizontally? These are different options that are available too. I've already shown you what happens when we do the question mark. All right, so we can also do some fun stuff. For example, we could take a look at all the resources and show the status in the description, and we might want a pretty table rather than like a list. So in Julia, what you would do is for class-like objects, you can use the get property function. So if I were just to, let me just comment this bit out. Right, so I'm grabbing center data here. Okay, hang on, there we go. And now what I can do is, oops, I can say, well, let's grab all the names. And the way you would do that is you would use the get property function. The little dot here means apply this function to every input. It's a broadcast operation, basically. And I'm grabbing the name field out of the center vector for each element. And so then, for example, I would get an element of all the available resources at NERSC where we have a status field. And you can do that for description and for status. And so if I were to like uncomment this bit here and run this, takes a second because I'm rerunning this. Okay, and we get a pretty little table. Isn't that nice? All right, so that is one way. For example, you can use the Superfacility API to build dashboards in Julia for you that sort of summarize data center status and so forth. Now, I've tried to pretty much do everything that Nick does. So the next thing that Nick was looking for are outages. And this stuff should start to look familiar. So we can, for example, just query the outages, the standard outages, and we'll get this ginormous blob of data, right? Because there's a lot of information we provide here. And again, this is wrapped in a result type. So if I take my outage data result object, I can use the unwrap function to grab the content of the result. This will throw an error if it's actually an error. So the reason why we use result and error types is that you don't want to force people to constantly use try catch everywhere. Instead, what you can do is you can just take, if I, for example, say this, let that run. So I can go is error result types dot is error. I can do that, and it's not an error, so that's great. It means no error has occurred. So you can kind of programmatically react to the outputs of the Superfacility API. This is a really important design pattern when you build REST APIs, because things can return errors, right? Like your endpoint might not be available, you might have a misformed input, something like that. So build your pipelines to be tolerant to failure. Anyway, so we unwrap that, and then we would still get this just absolutely ginormous blob of data. So what we're going to do is we're going to filter this list here. And the way it's structured is it's a list of lists. So we're going to get the first element out of each list in the list of lists. We're going to look at the name of it. And if it's Perlmutter, then we pass this along. And so this way, we would get, here we go, lots of dictionaries with data about Perlmutter outages past and future. I haven't gotten around to creating a Julia object to represent each one of these entries. And therefore, rather than up here, you were using get property because we had structs. Down here, you would use get index because you're indexing into a dict. And so if we do that, this takes a moment again, and then you can see like this is the full list of outages for Perlmutter that we have published in the SuperFacility API. It's pretty big, so let's filter it for recent outages and upcoming ones. So what we do is we're going to start our search window at now, and we're in the Los Angeles time zone. We're going to subtract 2 months, so we're going to go 2 months into the past. And now we're going to say, well, we're going to take the Perlmutter outages and we're going to take all the ones that are less than 4 months in the future and greater than, you can actually flip these around. It shouldn't matter. Famous last words. There you go. And so now, so what this does, by the way, this thing here, what it does is it takes the start at field and it turns it into a zoned datetime. And that then allows us to use these mathematical greater than, equal than, and plus operations. So that's kind of helpful. You can kind of do math with time zones. Oh yeah, it's important that you zone the datetime because the SuperFacility API appends the time zone to the output timestamps. So that's what these bits here are. All right. Now, the authentication. Authentication works more or less the same with some subtle differences. So I want to make sure that we look at those as well. The first one is we require the keys in PEM format. And the whole thing is set up in such a way that you can just take the privkey.pem and the client ID from Iris and just move them into whatever location you want. The previous example used your home folder and then /.superfacility. So we're going to use the same location. And so I'm just going to do that. And you can see, yeah, I'm not going to run this one. This would show you a bearer token with which you could do things on my machine. So I'm not going to run that. But you could, for example, run the token fetch command, and that would fetch you a bearer token with which you can interact with Perlmutter. So what I'm going to do is I'm going to use I'm going to suppress output here. So you're not going to see what that output is, but I can go and run this. And so now I can use the account.user front end to create an account object for me. And that contains everything. It contains my phone number. Yikes, I didn't know that. Yeah, please don't screenshot it and send me messages at all hours of the day. But it contains, helpful things like my email and my name and my username. You can go and also interrogate what it does. And you can see this is all the information we have. And again, I'm going to suppress output, but you don't have to. Just remember, be careful if you didn't suppress output and then you shared screen. Someone could I don't know, if they were ready for it, they could use OCR and grab a bearer token. The model that the SuperFacility API uses is it uses the client to generate bearer tokens. And so we have this dot refresh function, which looks at the expiration timestamp and just refreshes it when you get close to that timestamp. So we just, this would be a no-op if your token is still fresh. And then you can use this, for example, to print all your projects that you want. It's good practice to just refresh it every time you need a fresh bearer token. Again, it's a no-op if your token is still valid, and so we can just run this, and you can see a long list of the projects that I work on and all sorts of information available. So I'm printing it using the JSON output, otherwise you'll just see a big blob again. All right. Now we're gonna start deviating a little.
Johannes, hello. There's 9 minutes left. Just want to give you a heads up if you can do it in 9. I mean, I think we want to give the people to say something in the end, maybe 5 minutes. Okay, we finished 5 minutes earlier, so maybe pick something. If you could jump to something.
Yeah, so this is the bit that really deviates from the Python API, mainly because I did there's limited time available, but also because Julia has its own tasking environment. So maybe I'll show you that, and then you can do the rest later. So so this is the same as previously. We're going to grab our home and Scratch directories, and we can we have the same ls option interface as the Python API. However, if we want to actually execute commands at NERSC, then the way that this works is we have a command object that will immediately spawn. I saw that, Björn, and I disagree. We can spawn a Julia task in a separate thread that will run this command at NERSC. So, for example, I can run this thing here. Now it says it's it immediately returns, but that's just because it returns the task object. So, for example, we can turn that into a Julia task, like so, and then we can use the isTaskDone operation to see if it's done. And then we can fetch the output, and you can see these are this is the ls from my Scratch directory. The way you would, for example, use that, I'm just gonna show you here. So this task actually takes 10 seconds. So I'm gonna create a script, I'm gonna run it, and now I'm gonna look, and you can see while the task isn't done, we're just gonna spin. This is a spin weight. You wouldn't really be building algorithms out of these. What you would do is you would overlap tasks, and you can use the and you can basically, the idea is you can build tasks to be dependencies of each other in Julia, and then this will automatically mesh to tasks running in the SuperFacility API. Now, the reason why I'm using this example here is because fetch actually blocks until task is completed. So, so that's why there's this little spin weight here. And yeah, I didn't really want to create a convoluted example. You can substitute your own workflow here. All right, and the way that this deviates from so this is one way it deviates. The other one is we're using a horrible hack at the moment to upload and download files. And that's just because we haven't finished the upload and download endpoints. So if you currently wanted to upload a file, you would create a task that just cats the content of a file to a file at NERSC. And we are working on improving the API. So hopefully we'll have the same kind of interfaces as we have with the Python front end. But right now you're gonna have to use this hack. All right, I think I'm gonna leave it at that. There's some discussion about how to interact with jobs, but I kind of, this is documented here, so I think we should switch to the Q&A.
All right, everyone, we answered as much as we could during the doc. Let's see. Okay, I take a look at the doc that your question been answered. Otherwise, I'll open the floor for any verbal questions now.
Do you have any plans to, I guess, have other facilities, non-Perlmutter facilities, support the same API, or is this NERSC